Well, guys, let's take a look at choosing data types in this next video. Now, we just talked about how variables and constants are assigned values, and how in the memory it records the human-friendly name, and we said it records like a value, and what behind the scenes actually really storing is not like A or 10 or whatever. It's actually storing ones and zeros to represent that value. So it'll be something like this, or 10 would be, I don't know, something like that, whatever. So this is what the computer sees. This is what you see, and of course that's has to be translated from computer to human on an ongoing basis when you're moving back and forth in the editing tools or when the program's actually running and displaying stuff to the human. So computers really don't care about what type of data you're using, whether it's integers or character data or even pictures. It's all just ones and zeros to it. However, it is important for the computer to know when something is different than something else. Like 10 is definitely different than an A, at least for the humans it is. And so data types allow you to kind of indicate that this is character data and this is integer data, or this is floating point data. And to do that, what they do is they type or categorize the data. This is a character type, this is an integer type, this is a decimal or floating point type. That's the way they kind of organize things. In most programs, if you have already set X to a character type, when you try to put in a numeric type, it complains. Or if you were to take the Y, which had a value of 10, and you try to put in something else, it would complain. Python strives to be friendly. Some people hate that aspect. Some people love that aspect. I don't know. I go back and forth. To me, it seems kind of sloppy that if you set Python to use character data on X originally, you can later on change it to integer data and it's still happy with it. Now, for the most part, this works invisible to you. Python just takes care of it. Occasionally, something comes up where it doesn't quite work the way you had hoped. It's not all the time, but occasionally it does. So let's take a look at an example of that. What would happen if I take X and I add Y to it? What is 7 plus A? Let's see if Python has an answer for us. It does. It answers that it's unsupported. You can't take an integer on one side of the plus sign and a string on the other side of the plus sign and try to add them together. It doesn't like that. That's because internally it sees X as an integer and Y as a string of characters, a string of individual characters. The most common data types you have are indeed string and integers, but you also have things like floats and Boolean values and some other stuff too. These four here, string, integer, float, Boolean, these are Python's primitive types, very commonly used in programming. When you choose a variable, you can sometimes hint at what type you want to store it under. For example, if I were to go through and put quotes around the 7, it's still a 7, but it's telling Python to recognize it as a string of characters. And you can take characters and run them together. This is called concatenation. Python has no problem with that. Now, since this is all happening invisibly, it's a little hard to see. No real pun intended on that one, but it's true. What I like to do is I like to actually indicate what I intended to be in my program by putting a prefix on my variable names. So in my mind, when somebody looks at this code, yes, it's a little longer to type, but integer first number is pretty clear that I intend it to be an integer. And like integer second number, also pretty clear it would be an integer of some type. If I wanted to make it a floating point, I'd probably put in some other prefix, like FLT. I'll try to keep the prefix 3, STR for string, Boolean, DLN. There's also other data types out there besides the primitive data types, and as I go through the class, I'll show you them. But I think you get the idea that it just makes it more transparent to people reading your code later. One of those people might be you, but it could also be your coworkers. Now, Python has a function called type. Type is kind of handy because that way you can take a look at what type Python chose for your data. I'll just go through and say I want type to be I want to know the type of int first number. Now I gotta admit the typing is kind of a pain. However, next week we're going to get into using a different piece of software that makes typing much easier, and actually just makes programming much easier in general. It's a little complex, but for the first week or so, but we'll see it later on. So don't worry about the long names now. Just realize it will get better as time goes on. But the code's pretty easy to see. It just says, okay, show me the type of this variable. And I'll go ahead and run this code. And you can see that it considers it an integer. Now let me change it over to have something with a decimal point run the same code. Now it thinks it's a floating point. Put quotes around it. Now it thinks it's a string. Now it doesn't really read the prefix. The prefix is only for humans to interpret that. You hope the human makes an educated guess about it. If you are actually going to change it to, or recommend it holds a string of characters, you probably should change the prefix. It's up to you. I mean, Python doesn't really care. That's completely a human-friendly name that you just completely make up. Up to you. In my mind, using code that is easy for other people to read is a good programming practice. Other professionals believe that making your code obscure keeps other people from knowing how you did it, which may save your job. I think this is a very short-sighted way of looking at things, especially if you have to be called in on a Sunday because nobody else can read your crazy code. So I would strongly recommend you make your code easy to read and also make it consistent. This pattern here is called camel casing. It starts off with a lowercase letter and then it has little humps in the middle. I did not make up the name. It's been around for a long time. Pascal casing is the one I talked about in the previous video. It starts off with a uppercase letter, and for variables I recommend you use camel casing for variables in your program, and we'll see some other conventions as we go forward. The key thing here, guys, is be consistent and try to identify what type you expect Python to interpret it as. This will help you in troubleshooting your code later on and also help you to troubleshoot other people's code at a later point in time. Okay, that's enough talk about the Python types for the moment. We'll see more examples going forward. Next video. I'll talk to you then.